In this example problem, we're supposed to find the area between these two curves. If I start with the first, y equals 1/2 x, that's just a line. It has a y-intercept of 0 and a slope equal to 1/2. Remember, slope is change in y over change in x. So we're going to be going up 1 and over 2. So my y-intercept starts there. I go up 1 and over 2, up 1 and over 2, and so on. The pattern continues on the other side, 2 down 1 and to the left 2. Still gives me a positive. And so that's the graph of my line, y equals 1/2 x. The other curve is a parabola. Since y is squared instead of x, that means this parabola is going to open left and right instead of up and down. And since my a here is positive 1, that means this parabola is going to open to the right. To find the vertex, we could just plot some points. You could just plug some values in for y and see what you get out for x. To find the vertex, when we have y equals a function of x, the x-coordinate is negative b over 2a. If I've got x as a function of y, the y-coordinate then is equal to negative b over 2a. So that's negative. B is negative 6. I get 2 times 1. So that's negative 6 over 2, which is going to be a y-coordinate of positive 3. Right, negative of a negative. My x-coordinate then is going to be y squared minus 6y plus 12. And I'm going to plug in 3. So 3 squared minus 6 times 3 plus 12. 9 minus 18, negative 9 plus 12 is 3. So my vertex here is going to be at the point 3, 3. So that's going to be here. I'm going to need to find where these curves intersect. I know it's going to be opening to the right, so it's going to be doing something over here. I need to figure out where is it going to intersect this line. So I need to set those equal to each other. I need to set the x-coordinates equal. So my first x-coordinate, oh, I don't have that. Okay, so we've got y equals 1/2 x. I need it as an x-coordinate, so I'm going to have to multiply both sides by 2. So that's going to be 2y equals x, or the line, another equation of this line is x equals 2y, right? Both of those are equations of the same line. So I'm going to set 2y for the line, and then for the parabola, my x-coordinate is y squared minus 6y plus 12. So I'm going to get things equal to 0. I subtract 2y. Negative 6 minus 2 gives me negative 8y plus 12. And when I factor this, then I get y minus 6 times y minus 2. So I get y is either equal to 6 or y is equal to 2. But for my line, I've got x equals 2y. So x would be 2 times 6, so x would be 12. So this point is 12 comma 6. Now, I don't have that on here, so we're going to have to imagine that. Here we get x equals 2 times y, x equals 2 times 2, so x equals 4. So this is 4 comma 2. Now that one I see. 4 comma 2 would be here, right? And the parabola is going to do something like that. And it's going to be at 12, 6. Over there is where it's going to intersect eventually, okay? So the point 12, 6 is where that's going to that's the point where that's going to intersect there. and we got this 0.42. The problem is, if I'm going to try to do vertical rectangles here, it would be okay on this part. I'd be going from the red graph to the blue graph, but this little business here, right here, if I try to draw a rectangle there, it's going from the blue graph to the blue graph. It's going from the parabola to the parabola. And that's not okay for my limits of integration. So I'm going to want to set my rectangles here so they're going horizontally instead of vertically. Because then the left endpoint is always along the blue curve and the right endpoint is always along the red line, right? Even if I come down here and draw a little rectangle there, the left endpoint is along the blue parabola, the right endpoint is along the red line. And so to find the length of that rectangle, I'm going to need a value delta x. And so this x coordinate is on the parabola. That's x equals y squared minus 6y plus 12. This I've already sort of got it labeled here. The right endpoint is x equals 2y. So I'm going to have to take the right endpoint minus the left endpoint. So that's going to be 2y minus the y squared minus 6y plus 12. That's going to be the length of my rectangle, which is delta x. The width of the rectangle is going to be my little dy. I'm going to be integrating with respect to y to find this area instead of x. So for my integral, they're going to be y limits. So my lowest y limit is down here at y equals 2, right? My highest y limit is up here at y equals 6. So I'm going to go from y equals 2 to 6. I'm going to take 2y minus y squared minus 6y plus 12 dy. So again, this is my length, which is delta x, and this is my width. Okay, the length is this x length. It's from one x coordinate to another x coordinate, so I subtract the x coordinates. X is expressed in terms of y. So what do we get? Integral 2 to 6, 2y minus y squared plus 6y minus 12 dy. So 2 to 6, negative y squared plus 8y minus 12 dy. So negative y to the third over 3 plus 8y squared over 2 minus 12y, evaluated from 2 to 6. Remember to take the antiderivative. I increase the exponent by 1 and then divide by that new exponent. So I plug in 6. Negative 6 cubed over 3 plus 8 over 2 is 4, right? So I get plus 4y squared, 4 times 6 squared, minus 12 times 6, and then minus parentheses, negative 2 cubed over 3, plus 4 times 2 squared, minus 12 times 2. So negative 216 over 3. 4 times 36 is 144. Minus 72 plus 8/3 minus 4 times 4 is 16 plus 24. Just see how all your signs, right? Get the signs working right. Let's see, negative 216 plus 8. So that will be negative 208 thirds. We have plus 144 and plus 24, so that's plus 168. And then minus 72 and minus 16, so that's minus 88. So that's negative 208 thirds plus 80 over 1. So negative 208 thirds plus 240 over 3. So that gives me a final area of 32 over 3.